In the third question that we have, it's a very important question. In the first part, these two are two separate parts of the question, and these treat them as two different questions. In the first part, we need to find out the type of interference at this point P. If S1 and S2 are vibrating in the same phase and opposite phase, there are two cases, and the wavelength is given to be 2 meters. Now, let us take case A, case 1 in A, that is they are vibrating in the same phase. So, if they are vibrating in the same phase, the phase difference that will occur at this point due to both of them will be only on the account of k delta x, that is path difference, because there is initially no phase difference between them. Therefore, this k delta x, now let us find out the path difference. This is 3 meters, this is 4 meters, therefore this has to be 5 meters. Therefore, this is equal to 2 pi by lambda is given to be 2 meters into delta x, that is 1 meters. Delta x is the path difference. It travels, the sound from this point to this point travels 5 meters, and from this point to this point travels 4 meters. Therefore, the path difference is 1. Therefore, this is equal to pi. Now, the phase difference between the two waves meeting at this point is pi. So, whenever the phase difference is in odd multiples of pi, then we have destructive interference. Therefore, we will have destructive interference. Similarly, for case 2, that is if the sources are vibrating in the opposite phase. Now, in this case, delta phi will be equal to pi plus k delta x. Since they are vibrating in the opposite phase, they initially have a phase difference of pi between them, and another additional will be path difference, phase difference due to path difference. This is equal to pi plus again pi, that is equal to 2 pi. Now, whenever there is a phase difference of 2 pi or even multiples of 2 pi between two waves interfering at a particular point, then we have constructive interference. Therefore, we get the answers for our first part, that is if they vibrate in the same phase, then at point P we will have destructive interference, and if they vibrate in the opposite phase, then at point P we will have constructive interference. Now, let us look at the B part. Intensity at P due to S1 is I0 and intensity at P due to S2 is 4 I0. We need to find out the intensity at P if both S1 and S2 vibrate simultaneously, that is in same phase, and lambda in this case is given to be equal to 3 meters. So, we know that for interference we have a formula for pressure. This is equal to P naught pressure amplitude, that is this is equal to root over P naught P1 square plus P2 square plus 2 P1 P2 cos of delta phi. Now, we know that intensity is equal to P square upon 2 rho V. Therefore, intensity is directly proportional to P square, that is pressure amplitude whole square. Therefore, we can write intensity is equal to I1 plus I2 plus 2 times root over I1 I2 cos of delta phi. Now, you should remember this formula of intensity resultant when we have interference. Now, using this formula, we get the resultant intensity at that point to be equal to I1 plus I2, that is 5 I0 plus 2 times root over I1 into I2, that is equal to 2 I0 again, and cos of delta phi. Delta phi is equal to, since both of them vibrate in the same phase, therefore delta phi is equal to k delta x. This is equal to 2 pi by lambda, that is 2 pi by 3 into 1, because the path difference is 1. This is equal to cos of 2 pi by 3. This will be equal to 5 I0 minus 2 I0, that is equal to 3 I0. So, final answer for the intensity at point P if both S1 S2 vibrate simultaneously or in same phase comes out to be equal to 3 I0, and in this case when vibrated in the same phase there was destructive interference, and when they vibrated in the opposite phase they had constructive interference at point P.